Hello everybody, and welcome to the latest in the Design, Engineer, Build series of video podcasts from the Engineering Network. I'm Mark Sims, and today I'm in Evesham in Worcestershire at the home of ABSSAC with General Manager Phil Jones. Hi Phil, good to see you again.
Hi Mark, nice to see you again.
Today we're going to be talking about ABSSAC's in-house machining capability. Talk to me about why you've made that investment and what it brings for customers.
Well, traditionally we used to subcontract out all the end machining work for the lead screws, and what we found was it was difficult to find a reliable partner who could machine the screws at the right price and in the time frame that we needed.
So talk me through a typical process.
Well, the typical processes in machining the lead screw ends are turning and milling operations. That's why we invested in a mill turn machine. It enables to do all these operations in one hit, saving the customer money in set-up times and enabling us to deliver the parts quicker. When it comes to processing the customer's order, we always start with brand new tips in the machine. So the first thing that we have to do is load the new cutting tools into the machine and then tell the machine where those cutting tools are. New jobs are always started with fresh tools, so the first thing that we have to do is tell the machine where those new cutting tips are. And our machine is equipped with a tool presetter to make that job really easy. Once we've established the position of all the cutting tools, we can load the workpiece into the machine and find what we call the datum, which is essentially where we're going to start our machining process and take all the measurements from. Once we've done that, the first process is to face off the end of the workpiece to make it nice and flat so that we can bring in the centre drill for the centre support. The second process in machining the lead screw is turning the diameters to size. The machine that we've invested in allows us to turn the journals to a tolerance suitable for use with a bearing. Once we've turned the journal to size, we can use our burnishing tool to improve the surface finish of the turned surface. The next operation on this job is the turning of an external thread for a lock nut to retain the bearing on the lead screw. Once that's complete, the final operation is milling of the keyway for fitting of the motor coupling.
And what's the benefit for the customer of bringing all those processes in-house?
Well, as we're a dedicated lead screw and nut machinist, the customer can be assured that the parts will be delivered on time and to the correct standard.
And that presumably must all have implications for costs, quality and timescales for the customer.
Yes, it does, Mark. Because we're doing all the operations in-house on one machine, that's the most economical way to do it, and that saving can be passed on to the customer. Quality, we check everything before it goes out the door. Because we're a dedicated lead screw and nut machinist, we're geared up to do this, and so we can turn around the orders very quickly.
Brilliant. Thanks, Phil. Good to see you again. Thanks for having me.
Thank you, Mark.
And thank you for watching, and we'll see you again next time.